In this section, we're going to get into the first half of naming compounds. So there are a different set of rules for naming compounds if those compounds are ionic or if they're covalent. So we're going to get into that in a little bit. Just looking at a compound, you won't have to tell me if it's ionic or covalent. I will tell you that. There is a way to tell it, but you don't have to get that specific with them at the moment. Okay, so first up with ionic compounds, there is something called a polyatomic ion. So polyatomic, meaning multiple atoms, it's basically multiple atoms that act as a single unit in the compound. Okay, so you'll have two or more atoms in this ion, but it acts as a collective whole. Okay. So, for example, you have the hydroxide ion, which is an OH. Okay, you have a carbonate ion, which is carbon and 3 oxygens. Sorry. If you can hear the little dog paws on the floor, Elfie decided now was a good time to eat dinner. And then you also have ammonium here, which is 1 nitrogen and 4 hydrogens. Okay, so NH4. And then with each of these ions, you also have a charge on the full polyatomic ion. So like the hydroxide, you have a -1 charge. The carbonate, you have a -2 charge. And then the ammonium ion, you have a +1 charge. So if you ever see parentheses around a group of atoms, that's a clear indication that it's a polyatomic ion. Okay, but if you're looking at an ionic compound and it has more than 2 elements, one of your ions is a polyatomic ion. So if you see a polyatomic ion in parentheses and you see subscripts after those parentheses, that indicates how many of those polyatomic ions are in that compound. Okay, you have seen some of these before, but we're going to get more into that in this section. So these are your polyatomic ions. Okay, these are not all of the ones available, but these are some of the major ones. You are actually going to need to memorize these, so I would suggest that you take some time in class and make some note cards with them. So you need to know not only the formula for them, like ammonium is NH4, okay, you need to know the name, and then you also need to know the charge. Okay, that will become important a little bit later on. You'll see why that's so important. Okay, but you can see, got a couple duplicates on here, I just realized that, but you can see that there is quite a range of different ones here. So ammonium is actually your only positive polyatomic ion. It is NH4+. So it has a +1 charge. And then you have hydroxide and cyanide are pretty simple. It's just 2 elements, OH negative and CN negative. And then you start getting into sulfates. Okay, so when you get these names, let me actually cross out a couple of the ones that I just realized are duplicates. So I have an extra ammonium here and an extra sulfate. I will actually cross out this one up here. Okay, so let's see. So when you start getting into some of these, you see sulfite and sulfate. Okay, and then if you continue down, you see perchlorate, chlorate, chlorite, and hypochlorite. Okay, excuse me. Give me a second. Sorry. So the rule of thumb with these is that you have chlorate and chlorite are kind of your 2 base polyatomic ions. Okay, so the 8s and the ites. Okay, whichever one is 8 has 1 more oxygen than the one that has ite. Okay, so 8 has an extra oxygen than ite. But then if you go up to perchlorate, that will have 1 more oxygen than the 8. So perchlorate has 4 oxygens, while chlorate only has 3. And then hypochlorite just has one fewer oxygens than the chlorite does. Okay, so chlorite has 2 oxygens and hypochlorite has only 1. Okay, now for the most part, when you look at the chlorates and you've got your carbonate and the nitrate, okay, you have 3 oxygens. But then if you look at phosphate and sulfate, you have 4 oxygens. Okay, so it's a little bit different, and you also have chromate has 4. Okay, so it's remembering which one of those, which one of the 8s, and the either chlorate, carbonate, sulfate, nitrate, chromate, or phosphate, which of those have 4 oxygens and which only have 3. Okay, so that is part of the memorization thing here. But if you can remember that hypochlorite is the fewest number of oxygens, then you add 1 oxygen and you have the ite, and then you add another and you have the 8, and then you add another and it's per, and then 8. Okay. Then you have a couple other ones that are a little bit funky. You have acetate up here, C2H3O2. Okay, that's just another straight memorization. Hydrogen sulfate adds on a hydrogen to your sulfate ion, which is right here. And you'll also notice that it changes the charge. So the hydrogen has a +1 charge on its own. So when it gets added to the sulfate ion to become hydrogen sulfate, then you basically have the -2 + 1. So it becomes a -1 charge, like you can see here. Then you also have thiocyanate. Okay, so cyanide here is Cn negative. Thiocyanate, you've got the S, the sulfur, and the Cn. So cyanate, cyanide, it's in there. Dichromate is one that's a little bit weird and kind of weird to remember because you have chromate here, which is CrO4, 2 negative, and you would think dichromate, you would just double everything, but you only double the chromium. So it's Cr2O7, and then it's still a -2 charge. Okay, so a little bit weird to remember a couple things, but yeah. So again, note cards with these, great plan. All right, so now we get into naming ionic compounds. So first, this is kind of a little bit of what I was talking about earlier, how to recognize ionic compounds. So you are going to get basically one element from the red box here and one element from the blue. Okay, that's kind of a general thing. If you have a polyatomic ion, that is a clear indication that it is ionic. Okay, because you can only have polyatomic ions if it's ionic, right? But in general rule, one from the red, one from the blue, you have an ionic compound. Okay? And that's because you have the reds are your cations and the blue are your anions. So what charge does a cation form again? Forms your positive charge, and your anion is your negative. Okay? All right. Sorry, let me yell at my dog for a second. Okay, so the reason that you have one from the red, one from the blue is that ionic compounds have to have a cation and an anion in order to be complete compounds, in order to be stable the way they are. So cations, whenever you're naming these ionic compounds, you're always going to list the cation first. Okay? The cation name does not change from what's on the periodic table. So if it's lithium on the periodic table, it's lithium in the name. Right? Cations are really easy. And then you're going to change the name of the anion slightly. Okay? So it's important to know if it comes from the left side of the periodic table, it's not going to change and it's going to be listed first. If it comes from the right side of the periodic table, it's your anion, you're going to change the name slightly and it's going to come second. Okay? So usually when we're talking about anions, we're going to change the ending of the name on the periodic table to IDE. Okay? So chlorine becomes chloride, iodine becomes iodide, oxygen becomes oxide, okay? So things like that. So here are some common examples. You have fluorine becomes fluoride, chlorine, chloride, bromine becomes bromide, iodine is iodide, oxygen is oxide, sulfur is sulfide, and nitrogen is nitride. Okay, it does take a little bit of getting used to with these, so don't worry too much if you leave an extra letter in there. I understand that it does take some getting used to on all of this, like where to cut off the word, the normal element name, and then add on the "ide" ending. Okay, just so long as you have that "ide" ending, because if you change it to, say, bromite, that adds in oxygens, okay, because that is a polyatomic ion. It's not one that you have to memorize, but bromite is a polyatomic ion, so make sure that you have the D in there and not a T, okay? Okay, so when you are basically writing out an ionic compound, you have to worry about balancing the overall charge on this compound, because unless it's noted otherwise, the overall charge on an ionic compound has to be 0. So again, this is kind of jumping between the compounds themselves and the names. Prefixes are not used with ionic compounds. That will make a lot more sense when we get to the covalent compounds in the next section. And then some cations can actually have multiple charges. These are the ones that are found in the center of the periodic table. They are known as the transition metals. Okay, so the charge of the cation for this is written in parentheses in Roman numerals after the cation's name. Okay, so do you remember your Roman numerals? Okay, this is really simple. Okay, remember, let me get a pen here. Okay, so 1 is just an I, 2 is II, 3 is III, 4 is where it gets a little bit weird. You get an IV, okay, 5 is just a V, 6 is VI, 7 is VII, and then 8 is VIII, okay? And you shouldn't have to do anything more than 8. So if you just know these, that will get you through it, okay? I, II, IV, V, VI, VII, and then VIII, okay? Now, remember, these Roman numerals tell you only what the charge on that atom is. Okay, so if you see a copper 2, okay, like this, copper and then II, okay, so that's copper 2, it means that that copper has a +2 charge on it, okay? If you were to see a copper IV, okay, so copper 4, it means that that copper atom would have a +4 charge on it. All right. Now, when the number is written in Roman numerals, that doesn't tell you anything about how many of that atom there are. All it tells you is the charge on each one of those atoms. Okay? So that's a key thing to remember. The Roman numerals are only telling you charge. They are not telling you number of those atoms. Just simply charge. Okay, that is something that a lot of people get screwed up on. Okay, so remember, Roman numerals are the cation's charge, not the number of them in the compound. And on that note, we are going to pause here and pick up with the next video.